previous lectures, we have learnt about Norrish-type reactions in saturated acyclic carbonyl compounds. Today we will learn about saturated cyclic carbonyl compounds. Let's take an example of cyclic hexanon. It is made up of a ring consisting of 6 carbon atoms and a functional group C double bond O. So it is cyclic because it has a ring. It is saturated because only singly bonded carbon atoms are present except the functional group C double bond O. It is a carbonyl compound because its functional group is carbonyl group C double bond O. When cyclic carbonyl compounds are irradiated by UV light in the range of 230 to 330 nanometers, the carbonyl compounds undergo N to pi star transitions and enter singlet excited state, that is S1, from ground state, that is S0. From the singlet excited state S1, they enter the triplet excited state T1 through intersystem crossing ISC. In the triplet state, the alpha bond is cleaved homolytically to form acyl alkyl biradical. Note: acyclic carbonyl compounds can undergo alpha bond cleavage in both singlet and triplet states, but in cyclic carbonyl compounds only alpha bond cleavage occurs only in triplet excited state. This is because in cyclic carbonyl compounds they have very short singlet excited state phase. Singlet state enters triplet state through ISC as soon as S1 is formed. Triplet excited state, the reaction is 100 times faster than single excited state, and the energy gap between S1 and T1 is very small. So the cyclic carbonyl compounds will undergo alpha bond cleavage homolytically in triplet state and not in singlet state. Norrish type 1 reactions consists of two processes in cyclic carbonyl compounds. They are the primary process, formation of acyl alkyl biradical after homolytic cleavage of alpha bond, and secondary process or product formation by acyl alkyl biradical. In the secondary process, the different products are formed depending on different conditions. Let us see Norrish type 1 reaction in cyclic hexanon. Sorry, this is not pentanon, it is hexanon. Hexanon. Primary process. Let us see the primary process. Primary process, formation of acyl alkyl biradical. The cyclic hexanon, which is present in ground state S0, Upon irradiation by H mu, that is UV light, undergoes N to pi star transitions and enters singlet excited state, that is S1. This is the singlet excited state. Then through intersystem crossing, it enters triplet excited state. In the triplet excited state, the alpha bond, that is the bond adjacent to the carbonyl group. Here there are two alpha bonds, this one and this one. Either of the bonds can cleave homolytically. So let us consider this cleavage of this bond. Homolytic cleavage of alpha bond takes place forming two radicals. This bond cleaves and one electron goes here and one electron goes here, forming a biradical. This is acyl biradical with, and this is alkyl biradical. So it is called acyl alkyl biradical. This is the primary process. In the secondary process, that is formation of products, we will see different conditions. First condition, decarbonylation, that is removal of carbon monoxide occurs in gaseous phase to form a new biradical. This new biradical forms alkene and cyclopentane. Let us see how this happens. This is the acyl alkyl biradical. Upon irradiation by UV light, decarbonylation occurs. Then this bond, that is carbon oxygen double bond, one of the bond cleaves. One electron goes to this oxygen atom, another electron goes to this carbon radical. So as a result of which we get this new biradical and carbon monoxide gas. This is the new biradical formed by the decarbonylation, that is removal of carbon monoxide. Now this new biradical can form an alkene or a cyclic pentane. Let us see how it occurs. This new biradical, upon alpha hydrogen abstraction, this hydrogen abstraction, this is the radical, this is the alpha carbon, so this is alpha hydrogen, or this is the radical, this is alpha carbon. This alpha carbon has two hydrogen atoms here also. The alpha hydrogen abstraction can occur either from this carbon or this carbon. So as a result of which the bond between carbon and hydrogen atom is cleaved, forming two radicals. One radical will go to this carbon atom, another radical will go to this hydrogen atom, and this radical and this radical will form a bond. So we get a double bond here. This hydrogen along with this electron goes to this radical and attaches itself here. So as a result of which we get an alkene. Alkene because it is having double bond here. Okay, let us see it in this figure. Okay, this means this is CH2 radical. Each corner of this cyclic structure represents CH2. CH2, CH2, CH2 and CH2 radical. Now this carbon hydrogen bond cleaves. So we get one radical here on this carbon and another radical on this hydrogen, as a result of which this radical and this radical will form another bond. So a double bond occurs between CH2 and CH. So this hydrogen is abstracted with this radical. So we get CH2 H, CH2, CH2, CH, double bond CH2. This is the alkene. I represented this for your better understanding. Otherwise, this will do to write the reaction. Now, this is what happens upon alpha hydrogen abstraction by the new biradical to form an alkene. Then, another reaction is cyclization. Cyclization of the new radical. This radical and this radical will join together to form a single bond here, as a result of which we get cyclic pentane. So the new biradical by alpha hydrogen abstraction gives alkene and by cyclization gives cyclic pentane. Now let us consider alpha hydrogen abstraction by alkyl radical to form aldehyde in liquid phase. In liquid phase, this is the acyl alkyl biradical. This is acyl part, this is alkyl part. Upon irradiation by UV light, this carbon hydrogen bond cleaves, forming two radicals. One radical will go here, another radical will go to hydrogen atom. This radical and this radical will form a bond, that is double bond. This hydrogen atom is abstracted by acyl radical, as a result of which we get, this is CHO part, that is aldehyde. This is unsaturated part, so it is called unsaturated aldehyde. Let us see this in real structure. Okay, this is C double bond O, CH2, 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 CH2 is represented as CH and CH. Then this CH2 radical. This is one radical, this is another radical, this is acyl alkyl biradical. Upon irradiation by UV light, this carbon hydrogen bond cleaves, forming two radicals. One radical will go here, one radical will come to this hydrogen. This hydrogen is abstracted by this C double bond O radical. As a result, the hydrogen atom gets attached to C double bond O, and this radical and newly formed this radical will join to form a double bond. So this is unsaturated aldehyde. Now let us see what happens when hydrogen is abstracted from acyl part of the biradical to form ketene in liquid phase. So in the previous reaction we have seen alpha hydrogen is abstracted from alkyl part of the biradical to form an aldehyde. Here alpha hydrogen is abstracted from acyl part of the biradical to form ketene. In this also occurs in liquid phase. This is the acyl alkyl biradical. This is the acyl part of the biradical. This is the alpha carbon of the acyl biradical. This carbon-hydrogen bond cleaves upon irradiation by UV light and forms hydrogen radical and another radical on this carbon. This radical and this previously present radical will form a double bond. As a result, this hydrogen will be abstracted by this alkyl part of the biradical. So the hydrogen goes and attaches itself to this alkyl part of the radical. As a result, we get ketene. Now let us see it in structure. This is the C double bond O radical. This is CH2 part, CH2, 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 CH2 radical. This is alkyl part. This carbon-hydrogen bond cleaves, forming two radicals. One on this carbon atom, one on the hydrogen atom. This hydrogen radical is abstracted by the alkyl part of the biradical. This radical and this radical on this carbon will join to form a double bond. This is the double bond. This hydrogen will get attached to this CH2 radical, as a result of which we get a ketene. This takes place in liquid phase. Okay. Now, in presence of polar protic solvent, that is, polar protic solvents are water, methyl alcohol, etc. With water, the ketene formed gives acetic acid derivatives, that is C double bond OH. Let us see. This is the acyl alkyl biradical. Upon irradiation by UV light, the carbon hydrogen bond cleaves, and this hydrogen along with its radical will be abstracted by the alkyl part of the biradical, and this radical and newly formed radical will form a double bond. This hydrogen will be attached to this acyl part of the radical, as a result of which we get ketene. Now, water can be written as H plus OH minus. So what happens here? This is the structure of the ketene. C double bond O, C H double bond. This double bond is shifted to this carbon atom, forming a minus charge here. As a result of loss of electrons, this carbon will become positive. This positive carbon atom attracts OH minus group, and this minus carbon atom attracts H plus, that is proton. So as a result, H is attached to this carbon atom and OH is attached to C double bond O carbon. So we get acetic acid derivative here, that is C double bond OH. Okay. But with methyl alcohol, the ketene formed gives ester. As usual, upon irradiation by UV light, this bond between the carbon and hydrogen cleaves, giving rise to a radical here and a radical on the hydrogen atom. This hydrogen atom is abstracted with this alkyl part of the biradical. This radical and this radical will form a double bond. This hydrogen is attached here. This is ketene. In presence of methyl alcohol, can be written as MEO minus H plus. What happens in presence of this polar protic solvent, that is methyl alcohol? This bond is shifted to this carbon atom. as a result of which it will get minus charge on this carbon. Since this carbon has lost the 2 electrons, it will become positive. This positive carbon atom will attract MEO minus, and this negatively charged carbon atom attracts H plus, that is proton. So as a result of which we get C double bond O, OMe here, and CH here. This is nothing but ester. So when we treat this biradical with polar protic solvents, we either, that is water or an alcohol. With water we get acetic acid derivative. With methyl alcohol we get ester. So these are the products formed. Thank you very much for watching.